We didn't hear those beeps when we listened back to the recording, though. So, yeah, I think it's like beep, 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 and now you can start talking. It's recording, which we'll find out when all of a sudden it comes on. Yeah. All right, completing the square with and without surds. In other words, we're not going to get necessarily rational numbers or whole numbers or anything. So that's all right. We don't care. Question A, f of x equals x squared minus 4x minus 5. We have to complete the square with or without so that we can sketch the graph. All right. What is the first step we are going to take? Yeah, cool. We're going to find the y-intercepts. We're going to... What's up, guys? What's up?
Can you hear it?
Yeah, the band.
Oh.
They rehearse every Wednesday morning.
Oh, I thought it was like Minecraft music.
No, not Minecraft music, though they may be playing a Minecraft song. Who knows? One of the things I want you to look at in this particular thing is it wants us to sketch the graphs. If we're going to sketch the graphs, what are the process we need to sketch the graphs? So what do we need to sketch the graphs? What's the first thing? Before the intercepts even? Before that?
If it's up or down.
Yeah. Concave up or concave down? Okay. Go through the steps. Is this concave up or concave down? Cool. Concave up. So you don't have to do lots of formal writing for this. In an exam, maybe you'll want to write, okay, concave up. And why is it concave up?
Because there's no negative.
Yeah, the coefficient of x squared is positive. Okay, so the coefficient of x squared is greater than 0, therefore it is concave up. But you can just say concave up, or if you're lazy like me, sometimes I'll just do that so I know that it's concave up. It doesn't really matter. It is a tell for you. Okay, what's the next thing we need to know about it? Y-intercepts. What's the y-intercept in this case? Cool. Y-intercept is -5. Happy with that? What would be the next thing we need? Remember, we did have a list of things, and in fact, if you look in your book, even in your worked example book, there is a list. There's a step.
X-intercepts.
Right, x-intercepts, which are also known as the zeros or the roots. Now, there is a technical difference between roots and zeros, whether it's an equation or expression, but we don't care at the moment. We just want the x-intercepts. So the x-intercepts, how do we calculate them? That's when y equals 0. Cool. Now, the other thing that makes it easier is when we've already completed the square. Because what's the other things we need to know?
Axis of symmetry and vertex.
We actually, technically, we only need the axis of symmetry so we can calculate the vertex.
Yeah.
Because the vertex is at the axis of symmetry and it's just a straight line up from there. So that's all right. If we have the vertex, we don't have to then find the axis of symmetry. Cool. The axis of symmetry is just the x value for the vertex.
Yep.
All right. So if we want to get the x-intercept, we want to do y equals 0. But we just worked out an easier way of doing it, didn't we? By completing the square. Now, if you look at this question, you may realize that this question is actually one that we previously completed the square. What was our completed square?
X minus 2 all squared minus 9.
X minus 2 all squared minus 9. Okay? So I'll just get rid of the word x-intercept at the moment. That is our completed square. Everyone happy with that?
Yes.
So why does this make it easier? Because now I don't have an x squared that I've got to worry about. Because to get the to get the x-intercept, I want to make y equals 0. What will make y equals 0 in this case? Or what will if y equals 0, what do we get? -1 and 5. So if y equals 0, x equals -1 or 5. Okay. Let's have a look at it. If y equals 0, then I get 0 equals x minus 2 all squared minus 9, which means x minus 2 all squared equals 9.
Then you square root it, which is 3.
Plus or
minus.
X minus 2 equals plus or minus the square root of 9. So plus or minus 3. So x equals... So I've got x equals plus or minus 3 plus 2. So you can do it as two versions. So we'll go 3 plus 2 and minus 3 plus 2. So I've got the plus and the minus, which means x equals 5 or minus 1. Happy with that?
Yes, I am now.
So what are they? They are your x-intercepts. So we now have our y-intercept, which is minus 5. We have our x-intercepts, which are minus 1 and 5. Cool. You'll notice I'm labeling on my graph now because I've got a graph there already. But that's what I've got. We all cool with that? Okay. What next?
You draw the graph, don't you?
Oh no, you've got to find the symmetry.
Yeah, the axis symmetry in the vertex. So what do we know about the vertex? We know that the x value is going to be what? Yep. 2?
Yes.
What's the other thing you should know about that? So we know it's 2. Have a look in that bracket there.
It's minus 2. It's 2 minus 2, so it's 0. It's the vertex. Is minus
That x minus 2 tells you how much it's been shifted. Okay? So x minus 2 means it was shifted 2 spots to the right.
Which means it's positive 2.
Which means, yeah. So if you look at it and think, what value of x do I have to get in there to get it back to 0? I'd have to put in a 2. So that's where your vertex is. So if I had in the bracket x minus 7, my vertex would be at 7. If I had in there x plus 7, my vertex would be at minus 7. Okay, because I'm just trying to get that bracket back to 0. I'm trying to shift it back.
So then you still need to do the working out like
For the average?
whatever the x-intercepts are over 2.
No, you should start to recognize that number in there. One of the great things about completing the square is you now have the x value of the vertex sitting there in front of you. And it doesn't matter whether it's a fraction, a whole number, or a surd. All right. Now, how do we find the y value of it? Yeah, sub 2 in. So we end up with, what do we get?
Isn't it just minus 9?
Yeah, it's just minus 9.
Yeah, it literally says
Oh,
vertex
dear.
is k, comma k.
Yeah, sorry,
Right there.
that's mean to me.
So
it's-
I knew that you make me doubt
When you
myself.
chuck in that 2, you've made your bracket 0. When you've made your bracket 0, all you're left with is that constant that's not in there. So you've actually got the vertex sitting in front of you. Once you've completed the square, the vertex is sitting there. All you have to do is read it off. Cool? So we're at 2 minus 9, which is approximately there. Well done. Good pickup. I'm not going to complain that it took a while. Didn't take that long. Actually, that was quite quick. Average for a lot of people has been like 1 or 2 lessons. That all of a sudden they start going, oh, hang on. So
That's
Good job.
no, it's actually it's one of those things that they don't expect it to be there, and unless they, like you said, you actually read the bit that was on there where we said the vertex is the HK. Okay, the fact that you read that is important because that's telling you. All right, we're cool with that. So from there, you have the y-intercept, the x-intercept, and the vertex, and therefore the axis of symmetry. You already know it's concavity, so you should now be able to draw it. Everyone cool with that? Drawing a parabola, it is probably easiest if you don't have a parabola tool to draw from the vertex up. It doesn't have to be perfect, but the more accurate you can make it, the better. And if you've got a little bit of a pointy bit at the end, that's not technically correct. But if we're just sketching it, as long as you're going through it, I'm happy. Just don't stress about it being perfect. Okay. Everyone cool with that one? You can actually get rulers that have parabolas on them. Parabola shapes on them, which is kind of cool.
Like half times X and
Yeah. And the thing is with these, if you've got a parabola shape, you can then draw the Cartesian plane afterwards and assign the numbers. So you can always use the same Cartesian, like if you've got a nice parabola shape, you can then put the intercepts where you want them and call them what they want. And if it's a sketch, that's fine. Okay. What we want is the relative shape and the positions and all that. All right. Part B. Part B, we are going to do much quicker than we did part A. Why? Because we can. So, if we have a look at this one, we've got x squared minus 4x minus 1. Concavity? Cool. It is concave up. Excellent. What do we do next? Y-intercept is minus 1. You happy with that? Excellent. That's a good start. What do we do next? And how do we do that? Complete the square. Okay, so let's complete the square. So we've got x squared minus 4x. Now, when we're completing the square, you guys should be able to look at that and go, minus 4x, what do I have to put to complete the square? What? Halve it and square it.
4.
Yep. Plus 4. So we halve it and you get minus 2 squared.
4.
Okay, so that gives us our squared. And then don't forget to subtract 4 as well. And subtract 1. Because we're completing the square. Halve the coefficient of x will give you minus 2 and square that. Okay. We all good with that? And I should have put y equals at the front. So we get y equals x minus 2 squared minus 5. Yeah.
I have to leave it like a couple minutes early. That's okay.
Completely
Then
unrelated.
then
I'm going to assume that there's a good reason for it. So excellent. Thank you.
Leaving a few minutes early.
Huh?
I need to fix Mr. Miller's bike.
Yeah, that's not a good reason.
That's not good. What's wrong with the bike? They're rolling disc brake.
Take like 2 seconds. You do not need to leave early.
All right. We're cool with that so far? So now that we've completed the square, what have we also got?
The vertex.
Okay, so let's just write down I've written the vertex first rather than last, because the vertex we should be able to just write straight off. Okay, what's our vertex? 2 minus 5. Excellent. Well done. Okay, see how these are actually, they're getting easier. Once we get a bit of familiarity with them and once we start finding out what the process is, they do get easier. So how do we do, yes mate?
So if you do it to get the vertex from the original things, you just have the end term and half of the coefficient of the middle term with the sign flip.
I'll leave it with you to decide whether that's always going to work.
Yes, it is.
I'll leave it with you to decide whether it's always going to work. You can, like, on the questions, as you're going through them, see if it works. And just check. I mean, obviously you could do it algebraically and prove it, but we're not really going into that right now. But you can decide. And if you feel that it does, come back to us and let us know.
Okay.
If we just did that and just got the vertex straight away, would we still get full marks?
Yeah. It's not about, like, what I'm assessing. If I was assessing you, unless I said by completing the square, and then I'm assessing whether you can complete the square, because there's other reasons to complete the square, like I was talking about with my guys and having to use it for complex numbers and vectors and stuff like that. Okay, there are other reasons, but in this particular case, we're completing the square so that we can draw a graph. And unless I specifically say do this by completing the square, then you can do this any way you know how. Does that make sense?
Yeah.
It really depends on what I'm assessing. So if it was just a question that wants you to graph stuff, then do it with any tool you've got.
This says complete the square.
This particular question is asking you to complete the square because the actual topic we're doing in functions is completing the square.
So you can't do the vertex just like that? Huh?
Like I've done.
Yeah.
Yeah, because I completed the square. The completing the square was this part.
So you can only do that when it says complete the square.
No, you have to do it when it says complete the square.
Yeah, so I said you can only do it when it.
No, you can do it anytime you want.
It doesn't have to say complete the square for you to complete the square.
If I said to you, I want you to go down to the hangar and you have to go via Chestnuts.
Yeah.
Okay?
Uh-huh.
That would say to you that when I go down to the hangar, I have to go via Chestnuts. Cool? But if I said to you, go down to the hangar, that doesn't mean you can't go via Chestnuts. And it also doesn't mean you can't go via that side. Okay? So if the question says, solve this, graph this by completing the square, then you have to do it by completing the square. But if it just says, solve this, graph this, then you can still use completing the square if that is the tool that you choose.
I was saying, how can you just get to the vertex just like that?
When you say like that, what do you mean?
Like, you don't prove it, you just go straight.
You just
Two
pull
minus
straight
five.
out.
When you say don't prove it, what do you mean?
Like, you didn't write anything to prove it.
Yes, I did. I completed the square.
Cameron, you got to remember this is better than Mrs. Potty. You don't have to show 50 million lines.
This one?
Yeah.
Yes.
Okay. So will we get marked down?
No. Unless you get it wrong. Yeah. It's one of those ones that if you can do it that way, go for it. But if you get it wrong, then you've got it wrong. All right. Yeah. So sorry if that's not making sense to you,
I'll figure it out.
but you have proven. Okay. I think I know what you're saying. Okay. If I said to you, find me the area of a square, and I gave you a diagram with two sides, or the area of a rectangle, and I gave you a diagram with two sides, could you find that?
Yes.
Okay, because you know the formula. Okay, do you have to prove that that formula works before you can use that formula? No, and that's the point here. See how we've got it here?
Yeah.
You no longer have to prove that. So you can use that. That is something that you can take as proven. Does that make sense?
Yeah.
I think that's what you were asking. Yeah. Okay. Cool. So we. Yeah. You have.
Mrs. Potty makes us do work and everything. Like,
You've done the working.
I know, but like, if
There-
you wanted to get it out, you'd have to actually solve it. You can't just pull it
Yeah.
out.
You did that in year 10. Same as when you're in like year 1, you might draw a grid on a rectangle to show that you can just do them add repeated multiplication or repeated addition.
We're
Sorry.
just better now.
Sorry.
We're just better now.
Yeah.
You just think we're slower than we are.
No. This is an assumption. I've already given you this and said this is truth. This is now what we call axiomatic. Okay. It is given to be true. All right. You can now use that and go, the vertex is HK when I've got it in the form of A outside of X minus H all squared plus K. You can now use that. It's all yours. Any of the things in these blue boxes, any of these formulas or identities that I give you in these blue boxes, we have already done. Like we went through and we did it up here. We've already proven it. Okay. So now that we've gone through that, I do not expect you to prove it every time. This is now a tool you can use. Okay. Yeah. No, I see what you mean by, last year you would have been expected to show it every time. But now we're at the point where you don't have time because this is actually going to be such a minor part of a question. This is going to be something you do as an aside to help you solve a question further down the track. So you don't get the opportunity to go, I'm going to prove that 1 + 1 is an integer, and it's just not. Yeah, it is. It is. All right. Are we cool with that? So once we get to these blue box stages, those things in the blue boxes you can take as axiomatic and you can use them as identities and proven things. Okay. All right. So we've got x-intercept. Sorry, how do we work out the x-intercepts? Yeah. So one of the things you kind of need to do is you do need to do this whole when y equals 0 thing so that we know what's happening with it. Okay? So when y equals 0, we sub it in there, and what do we get? I'm just going to immediately go to x minus 2 all squared equals 5. I've just shifted the 5 across straight away.
Yeah,
Am I cool with that? Because that way it's done. And now what do I get?
square root.
Yep,
What do you got?
I have moved off my page, sorry. So I end up with x minus 2 equals square root of 5.
Correct the window. But then, so we just leave it as 2 plus root 5 or 2
Yes.
minus root 5.
So you end up with 2 plus root 5 or 2 minus root 5.
Oh yeah, and then you just write that on your graph.
You will now have to put that on your graph.
Yeah.
Okay, so we've now got the x-intercepts. At this point, there is going to be some of you who look at that and go, hang on, 2 plus root 5, 2 minus root 5. Are they numbers?
Yes.
They are. They're just numbers. Square root of 5 is a number. Okay, so you may have to, if you're not certain, you may have to put it into your calculator to just double check where that would be. However, you should also be able to go, the square root of 4 is 2, the square root of 9 is 3, square root of 5 is in between those two. So it's going to be in between 2 and 3. So 2 minus something that's a little bit bigger than 2 will get you a little bit past 0. So you start to get an idea of where things are located. You can chuck it in your calculator to go 2 minus root 5. What do you get? You'll get minus point something.
0.2.
Yep, cool. And then 2 plus that, you'll get what?
About 4.
Okay. So you've got a little mark there. That will be your minus, it'll be your 2 minus root 5. And then over about here will be 2 plus root 5. Now, this is a sketch. You do not have to have 1, 2, 3, 4 and all them on there and then have this perfectly placed in between them. You can just put your intercepts on there. As long as you've got them on the correct side of the axes and as long as you've got them approximately where they would probably sit. So one of them's at 0.2, one of them's at 4 point something. 4 point something? 2 point something? 4 point something. Okay, so as long as they're there, and then when you do your intercept, if you've got an intercept that should be a negative, like this one, 2, -5, then try and get it in the right spot. You want to go about halfway between them, and that way you go 2, -5. As soon as you label it, you've told us where it is. And as long as your scale is not wildly out, you're going to be fine. Okay, you got concavity up, you've got your vertex, you got your intercepts.
What the doodle for?
Yep, your y-intercept is the other one. Thank you, Felix. What's your y-intercept? -1. So about there. Well, I'm having trouble. I'm going to have to move my y-intercept up a little bit. So normally what you do is you draw the graph and then put the y-intercept in because that way you don't have the problems I'm having. I'm going to make my y-intercept there. That's terrible. You get the point, though.
Mum's terrible as well, sir.
It really was, but we accept.
Thank you, Cameron. Sorry, Cameron. Oh,
That'll do.
-1.
So,
-1.
yeah, -1.